Okay, back to similar figures. Figures that have the same shape are said to be similar. Define figures that have the same shape but not the same size. Okay, here's like a little diagram here. The symbol is this little squiggly line thingy right here. You see a little squiggly line? That means about or similar. They have corresponding angles. I can't see that. And what does that say? Sides. Corresponding angles and sides. And you use a proportion to solve the problem when working with similar figures. You know how to solve proportions? Okay, do all of you know how to solve proportions? Yes. Good. So answer me when I ask you a question. I gotta get one of these because I can't see it. You use proportion to solve problems involving similar figures. On the right over there, it says a scale drawing. So a scale drawing is a proportional two-dimensional drawing that is similar to an actual object. Scale drawings can represent objects that are smaller or larger than the actual object. So that's where we'll be going. And right here on these little triangles, do you see them? How they would be? Do you see the two triangles? See them? That's kind of where we're going with that. Okay, let's look at the important properties. Number 2. The corresponding angles have equal measurements. The corresponding sides show a proportion. Form a proportion. That's what I wrote up there on the board. And then number 3, use proportions to determine if two figures are similar. Step 1, write a proportion using corresponding angles. Step 2, cross multiply. Step 3, compare cross products. If equal, they are similar. If not equal, then they are not similar. So basically what we've done here is we have 32 over 24. That is white, and you will not be able to see that, will you? 32 over 24, you guys don't have to write this. What I'm doing is right here, just making a line right here and right here just to make the proportion equals 20 over 20. Now you probably know already that that's not proportional, right? Because they're different, and that's a square. But what you would do is multiply the cross products, and if they're different, they are not proportional. If they are the same, then they are. With me? No. Next page. When two figures are similar, the ratio of the lengths of their corresponding sides are also equal. You try. Are the polygons similar figures? What's a polygon? A what?
Five-sided shape.
What?
No.
What? Say it, Yvonne.
Is the shape closed? I mean, that is closed.
It's a shape that's closed. It's not a circle. So it is a 3 or more sided closed figure as a polygon. Okay, so we're going to figure out if these are similar. So basically here is our fraction line. Does everybody see this here?
Yeah.
So you could do 2.8
Yes.
over 2 equals 7 over 5. So they're the corresponding sides. We got our, see right here, this one goes with this one, right? So we have them together. So we would just cross multiply and see if we get the same. I'll do the 2 and the 7. It's 14. Y'all do the other one.
$14.
14. So are they similar?
Yes.
Yes. That's pretty simple. Yes? You agree? Of course, it's not that easy, right? Step 4. If you know that two figures are similar, then you can use proportions to determine a missing side length. So step 1, write a proportion using corresponding sides. Step 2, cross multiply. Step 3, solve the one-step equation. In the figure below, triangle ABC is similar to triangle DEF. What is the length of X? So this is when you have a little choice to make here. So we're looking for X. So we have to use, what is X's corresponding side? 12. The 12. Now you can use whichever other ones you want. Which ones do you want to use? Do you want to use the 10 and the 10 and 20? So I like to box them in and, the ones that go together. So now I'm going to have 20 over X equals 10 over 12. Now, can I cheat here?
Yes.
Yeah, I can actually cheat and go backwards, timesing by what? 2. So what's X? 24. So the hardest part of this is knowing which sides correspond to each other, because eventually they're going to want to flip those shapes around, and you got to figure out which one's corresponding. Sometimes they won't always be just perfectly set. Oh my gosh, yes, I want to leave. Okay. Next page, you try. Some of these are so super easy, you're going to be like, really, Miss Milliken? Come on now. All right. The pairs of figures below are similar. Find the value of each variable by setting up a proportion and solving. Blake, you should probably use the sharpener over here on the other side. That one does not work. So we're going to set up a proportion. I like to put the line right here and right here. What's our proportion? Equals. So we can't cheat here, so we actually have to do the cross multiplying, right? So I get 6y equals 45, right? So what do we do now? Divide by 6. So y'all do that. Do you get 7.5? So y equals 7.5. And the next one. Solve each similar figure problem by setting up a proportion and solving. The front of Jane's house is similar in shape to the front of Spot's doghouse. The base of the doghouse is 5 feet and the height is 6. If the height of Jane's house is 30 feet, what is the length of its base? What is our proportion?
675.
And can we cheat here?
Yeah.
Yeah, you can go this way. Multiplying times what?
5.
Times 5, which gives you
25.
good. It's pretty easy, right? So y'all do number 2 on the next page. And what'd you get?
3.
What?
3.
Oh, I did it wrong. 3?
Yes.
Good. We're not going to do 3. We're going to do 4. So we did it, so turn the page. Let's look at number 6. A rocket casts a shadow that is 91.5 feet long. A 4-foot model rocket casts a shadow that is 3 feet long. How tall is the rocket? So our proportion is going to be h over 91.5 equals 4 over 3. So I can't cheat, so I might as well just 91.5 times 4. Did you get 366? And then we do what?
Divided by 3.
Did you get 122?
Yes.
Good. Turn the page. I don't want to look at some of these that are flipped around on you. Like number 9. This is what I mean by the shapes being flipped. You gotta make sure you know who goes with what. So if we do number 9, who's gonna go with X on the other shape? I think the 5, yeah. So we'll have X over 48 equals, can you cheat?
Yes.
Yes. What is it? 40. Good. Okay, I want to look at number 11 and 12. These are a little different. They've given you the scale. A particular motorcycle is 9 feet long. A model of it was built with a scale of 1 inch to 3 feet. How long is the model? These are pretty simple. That's why I put them on here without going into a lot of detail. I would just do inches and feet. 1 inch, 3 feet. And it's 9 feet. So where does the 9 go? Yep. So that's pretty simple. What does X equal? 3. Good. Look at number 12. A particular satellite is 15 meters wide. A model of it was built with a scale of 1 centimeter to 5 meters. How wide is the model? So we're going to say, what is it, centimeter and meter? And 1 centimeter was 5 meters?
Yeah.
And it's 15 meters wide. Where does the 15 go? Perfect. So what's the answer? 3. Again, 3. The next page is the you do. I want to look at number 1 with you to make sure you understand what I mean by you can pick. And then we're going to look at some of the other ones because I just want to make sure we get them. So on the you do, you have to use what number on the one on the left?
3.
The 3. You have to use the 3, but then you can pick which other 2 you want to use. You with me?
Yeah.
Okay. And I want to look at number 4. Everybody look at number 4. This is where the words become important. A 6-foot tall tent standing next to a cardboard box casts a 9-foot shadow. If the cardboard box casts a shadow that is 6 feet long, then how tall is it? What is it asking you? How tall? So the words I would use are tall and shadow. And go ahead and make my proportion lines. Now what do we know? We have a 6-foot tall tent, right? Cast a 9-foot shadow. This says the cardboard box casts a shadow that is 6 feet long. Where does the other 6 go? On the bottom because that's the shadow. Everybody with me on what I did there? I think you guys got this. It's pretty self-explanatory. Most of them are pretty simple. So there's 15 of them through page 9. Y'all can go ahead and work on those. It is 1:20. You've got 7 minutes until the alarm goes off, so you can work on them. If you don't finish, you can just do it tonight, and we will check them tomorrow.